Hello viewers, in this video tutorial, I kind of want to make a clarification on why we always reverse the inequality sign whenever we multiply or divide both sides of an inequality by a negative sign. So we'll be using a method called an inspection method. Basically, we'll be considering substituting some values and see what changes as we are changing the values. So this is what I'm seeing makes sense. Let's say we have minus x to be less than 2, for instance. So if this is a question that requires us to find the value of x, to get x, we need to divide both sides of the inequality by a negative sign. Or in other words, multiply both sides of the inequality by a negative sign. Thus, if we use the division, if we have divided by minus 1, for instance, then we would realize that x will now be greater than minus 2. Yeah, because we have to follow the rule of inequality, which says that we should reverse the sign whenever we undergo this process. That is the process of dividing by negative sign. Perfect. Now, why do we need to do that? Let's see. Inequality is a statement. Understand? It connects whatever you have on the left hand side and whatever you have on the right hand side. So the statement is the inequality symbol. The actual problem is that minus x is less than 2. What this statement means in essence is that whatever x is going to be, by the time we multiply with the minus sign, the result will always be less than 2. Now, since x can be anything, then there has to be a range of values that x can be. Now, when we get that, we said that can always be values that are more than minus 2. So, before I begin expecting, let's consider a situation whereby we don't follow the rule. Let's say we don't reverse the sign. So that is, dividing both sides by minus sign of the inequality, we now have x to still be less than minus 2. So basically now, we'll be considering values of x within this range and values of x within this range. And then connect it with actual statements and see the one that works best for us. That is, the one that will still follows the statement that makes sense, that will satisfy the statement. So x greater than minus 2, what are the possible values that x could be? Understand? When we say the greater, we are considering this one. So we need values that are more than minus 2. Now keep in mind, we are not considering minus 3. Minus 3 is actually less than minus 2. Am I complicating? Because it's a debt. Let's see like this. You are owing 3 naira and I am owing 2 naira. Let's say we are owing the same organization this small amount. Whose debt is still bearable, if I should ask you? Definitely mine, because I'm actually owing less compared to what you are owing. So I'm a little bit bigger than you. Yeah, I can see it. You understand? So minus 2 is always bigger than minus 3. And so does is the proceeding, the subsequent. You understand? That is, minus 3 is as well as greater than minus 4. You understand? So when you are considering minus sign, you don't look at the large value. You understand? Because as that values depreciate, that is how bigger it's going to be. When so far it is negative, you understand? But when it is positive, that's when you actually need to pay attention to its magnitude. That is, the bigger it is, then the bigger its power as well. Am I complicating? Perfect. Now, another way you can use to know what would be the possible values is to use your number line. I actually don't want this video to be too long, you understand? In your number line, let's say we have our number line centered at 0. Okay, to the right of your number line, you have positive values 1, 2, 3, and so on. And to the left of your number line, you have negative values minus 1, minus 2, minus 3, and so on. Perfect. Now, look at your inequality. We are actually paying attention to this. X greater than minus 2. So basically, you now go to minus 2 and then direct your arrow towards the peak, typically the end point of the inequality that's connecting your problem, which is actually towards the right. So thus, these are the possible values that X is going to be. That's how you can use your number line to get the corresponding possible values that your variable is going to be. Am I communicating? And the second one is to use the earlier method I showed you, that is by considering larger to smaller in order. Yeah. So now X can be minus 1, it can be 0, it can be 1, it can be 2. Now let's say when X is minus 1, if we put it here, with the end result, would it be less than 2? Let's confirm. So we have minus multiplied by minus 1. Okay, this must be less than 2. But let's confirm. Okay, minus times minus 1 is actually 1. Is 1 less than 2? Indeed, 1 is definitely less than 2. That makes sense. Yeah. Now, we don't want to consider just one digit to confirm our test. You understand? We are inspecting. Let's consider one more digit. So let's consider 0. Or I should move to positive values. You can consider 0 for you, if you want it. But let's consider a positive value. Yeah, let's say 2. So when X is 2, if we put it there, with the end result, would it be less than 2? Let's confirm. So we have minus times 2. Is this less than 2? Let's see. Minus times 2 is minus 2. Now, the question is minus 2 less than 2? Absolutely. Minus 2 is indeed less than 2. So thus, this should be the proper way of expressing our end results. Am I communicating? So that is the reason why you actually need to reverse the inequality sign, so that the statements will not change, so that your answer will not alter what the problem is in essence. Inequality, when you are solving it, all the process involved in solving must still be referencing back to the problem itself. That is, if you are switching whatever values in each of your steps, it must still be satisfying what that inequality satisfied. Am I communicating? So that is why when solving problems on inequality, you have to be very, very sensitive, very, very careful, so that you won't end up getting a value that doesn't satisfy your inequality. Back to the normal way that we're supposed to have the answer if we didn't follow the inequality rule. So X less than minus 2. So we need values that are less than minus 2. What will be these possible values? Think about it yourself. So we need values that are smaller than minus 2. Minus 3, excellent. Minus 4, minus 5, and so on. This value is smaller than minus 2, though they are both depths. You understand? But minus 2 is still bearable compared to them. You understand? Because the depth of minus 2 is still smaller compared to them. You understand? So those minus 2 is more than them, and so therefore they are less than minus 2. Excellent. So if you want to use number line, then you can still follow the rules. You start from minus 2, and then you direct your arrow towards the endpoint of the inequality symbol, which is towards the left. It means you are considering values like that. Perfect. So let's start with minus 3. If we put minus 3 as X here, would the end result, would it be less than 2? Let's say. So we have minus times minus 3. So this must be less than 2. So you know the answer already. But let's continue. Minus times minus is actually 3. Is 3 less than 2? Absolutely not. 3 is indeed more than 2. So this statement is actually wrong. Are we together? Perfect. So if you don't reverse the inequality sign, then it means you have altered the inequality statement. Thus, whatever result you'll be getting will not satisfy the inequality. So this is the reason why we actually need to reverse the inequality sign whenever we divide or multiply both sides of the inequality by a negative sign. Please, I hope this now gives you a clear insight and clarification of why we do reverse the inequality sign. So thanks for watching. See you in the next video. Bye for now. Bless.